Hi, I'm Derek, and today we'll be discussing creating bent and flat pattern sheet metal geometry in SOLIDWORKS. As sheet metal design transitioned from 2D to 3D, the manufacturers took the completed shape and backtracked the bend allowance in order to determine the flat pattern. It was up to the experienced workers to generate the correct part while doing these bend calculations manually. SOLIDWORKS sheet metal allows the designer to generate the completed 3D model while the flat pattern is automatically generated with the correct bend allowances. This can be quickly exported from SOLIDWORKS to a DXF or DWG for a plasma, laser, water jet, etc. Using SOLIDWORKS easy sketch tools, we can create our initial shape in 2D and then turn it into a sheet metal part using the sheet metal specific tools. We can even use a gauge table that is linked to your own custom bend tables. This way you know the bend allowances are going to be exactly the same as you currently use. No more calculating this on the fly. This also makes sure that the design and flat will be correct the first time. Wasting material with incorrect bend allowances can be a thing of the past. As we add more flanges and hems right on the fly, you can see how quick it can be to create. At each step, we can adjust the bend parameters based on the tooling we will use. SOLIDWORKS also allows us to design a flat and bend at specific points, as well as converting imported geometry to a sheet metal design in order to flatten it. SOLIDWORKS comes preloaded with a suite of forming tools, but you can create your own in order to punch the part to the shape you desire. Earlier I mentioned sending the flat out to a DXF, and it's extremely easy to do. We can even leave out punch geometry in order to not confuse our water jet. The flat pattern also gets automatically generated on a drawing with the bend lines and bend direction, which eliminate any and all errors during manufacturing. Designing sheet metal in 3D has huge benefits over manually drawing a flat pattern. It gives us the ability to see how our sheet metal parts fit with other components and how easily it might be manufactured. Another benefit of creating your sheet metal parts within SOLIDWORKS is you can leverage the functionality of costing. Costing allows you to determine the manufacturing cost of parts, including sheet metal. It calculates the bend cost as well as punching and cutting on a laser or plasma, for example. If your sheet metal is structural, you can leverage the functionality found within SOLIDWORKS Simulation to verify that your design is up to the task at hand. I appreciate you taking the time to check out this video, and if you would like to know more about SOLIDWORKS sheet metal, please reach out to your local CADimensions sales representative. Have a great day.